Why is choosing the right activation function critical for deep learning? Imagine building a machine that can learn to recognize faces, translate languages, or even create art. Now, think about what makes that machine smart enough to do all these things. It all comes down to the way its brain processes information. That's where activation functions come into play. They are like the decision makers inside each neuron, helping the network decide whether to pass on information or not. Without them, the network would be like a straight line, unable to understand complex patterns or make sense of the world. Activation functions turn the weighted sum of inputs into an output that moves forward in the network. They add what's called nonlinearity, which is essential because real-world data is rarely simple or straight. If you only used linear functions, no matter how many layers you stack, the entire network would behave like a single straight line. That means it couldn't solve tricky problems like recognizing images or understanding language. Choosing the right activation function affects how well the network learns and how fast it trains. For example, the rectified linear unit, or ReLU, is popular because it helps the network learn faster and avoids a problem called vanishing gradients. Vanishing gradients happen when the network struggles to update itself properly, slowing down learning or stopping it altogether. On the other hand, functions like sigmoid or hyperbolic tangent can cause gradients to shrink, making training slower or less effective. Activation functions also influence how well the network handles complex data. For classification tasks with many categories, functions like softmax are used at the output layer to give probabilities for each class. Variations like leaky ReLU or swish can improve learning in certain architectures by allowing small gradients when inputs are negative, which helps keep the network active and learning. Another key point is stability. Good activation functions keep the gradients stable during backpropagation, which is the process that updates the network's weights. If the gradients vanish or explode, training becomes unstable or very slow. That's why selecting the right activation function is so important for building effective deep learning models. In applications like natural language processing, image generation, or productivity tools, the choice of activation function directly impacts the quality and reliability of the results. For example, language models need activation functions to understand complex meanings, while image models depend on them to capture detailed visual features. To sum up, picking the right activation function is like choosing the best tool for a job. It helps neural networks learn faster, understand more complex patterns, and produce better results. Without it, even the smartest AI systems would struggle to perform their tasks effectively.